The influence line diagrams for statically determinate structure. So I hope now you do understand what is statically determinate structures. So this we are going to study beams, girders and trusses, how to draw the influence line diagrams for beams, girders and trusses. Today I'll teach you for the beams today. And then how to find out the maximum influence at a point due to series of loads, and then absolute maximum shear bending moment. Okay, so first of all, I don't want to jump in directly that what is an influence line diagram, but let me tell you what is the application of it. Where will you use in your real design? Any one of you? Bridges? Yes. Also, in some buildings where you have cranes moving on the beams. For example, if there is a train, if you see a train moving over a bridge, till now we have discussed the bending moment and shear force diagrams for beams in which the load was static. The load was not moving at all. You have a live load, but that live load was resting over the beam. The live load was not moving. But this live load is moving, and this live load is present over the bridges. It is not included in your book, but let me tell you, there are three types of live loads on bridges. Number one, there is lane load. Number two, truck load or train load. Number three, pedestrian load. Okay. Now the lane load. What is the lane load? Cars. Yes, you're right. Cars, small vehicles, small objects which are moving on the road. Even a small delivery truck, it is not included into the truck load. Have you seen the big trucks which have like 6 wheels? Yeah. So those are considered as truckload. And there is a standard truck which is known as HL93 truck. Standard truck, like 145 kilonewton in the back wheel, 145 kilonewton in the second back wheel, and then the front wheel it should have 135, and 4 meter. So this is standard HL93 loading given by the code. You don't have to remember. I think you will see maybe in the next part of your chapter. I think it is there somewhere in the next part. But what is lane load? Lane load is 3 kilonewton per square meter. If I remember correctly, 3 kilonewton per square meter. So how much is that? 3 kilonewton per square meter.
Means that in 1 meter square of an area,
3 kilonewton
acting on it.
So around 300 kg per square meter.
Yes.
So what we do for the moving load? Okay, first tell me one thing. You have two supports. For example, in the next. For example, there are two supports. One support here, another support here for a bridge. And it is simply spotted bridge. I mean, the beam or the girder is resting simply spotted. What do you think? When the train is moving, the reaction here and here, they are same?
No. At
every instant of time or distance, the reactions are changing. For example, when the train is here, the reaction will be
mainly on this one.
Mainly on that support, and here it will be about 0. Do you understand? So it means that the reaction will change. Before that, what you do, for example, if you have a dead load on a beam, you have a live load over a beam, you just put the loads, you find out the reactions, and those reactions were fixed values. But now, your reactions will change when the load will move. Do you understand?
Yes.
So there will be a diagram, just like the bending moment or shear force diagram. There will be a diagram for the reactions, and that diagram is known as influence line diagram. So what is an influence line diagram? Influence line diagram is that diagram which shows the change in force. What is the force? Reaction, shear and movement when the load moves from one point to another point. Do you want to see a sample ILD diagram for a reaction? It will be something like this. Did you understand? If you want some time for the group discussion, I'll give you note for you, okay? But this diagram shows the influence line function or influence line diagram for reactions. If you see at the top, it is written ILD, influence line diagram for reaction. Okay, what is this diagram? You will understand this diagram at the end of this lecture. I hope so. Let's start from beginning. Let's say there is a beam and the length of this beam is 10 meters. And this beam will carry a moving load. You know what we do? We draw the influence line diagram for unit load. Unit load. You mean what? You know what is unit load? Which is just one. Just 1 Newton, 1 kilonewton, 1 pound, 1 kg or whatever, but just one. For example, 1 kilonewton or 1 Newton load is moving from A to B. How will be the influence line diagram? So, what is the step? What are the steps to draw the influence line diagram? The first step, for example, I want to draw the influence line diagram for reactions for this beam. So, what would be the first step? The load is phase. Either Newton, 1 kilonewton, the load is unit. So what is the next step? I will divide into the number of parts. In how many parts you want to draw? You want to divide this beam. How many parts? Tell me. 5. 5. 3. You can do it. If you need more details, you can select more number of points. If you need less detail, you can select less number of points. It depends upon your effort. Less number of points, less effort. More number of points, more effort. For example, okay, let's divide it into 4 parts. 3, 5, let's take average. 4. Okay. So, this is the beam and I want to draw. I can do one thing. I can insert some object here. Do you like it? I think this object, well, it's not disturbing. Okay, so I want to draw the influence line diagram for this beam. So what I can do, the first step, I will divide into the number of parts. Number of parts, it depends upon how much is the time and how much effort you want to spend. For example, I will divide this beam into 4 parts. So it means each part will be
2.5 meters.
Yeah, like 0, 2.5, 5,
7.5.
and then 10 meters. And then I will calculate the reaction. For example, you should read in the exam. For example, I need the instance line diagram for reaction at A, for reaction at B. Because if the load is at point A, it will have two reactions. One reaction at A and other is at B. And when the load will move, both reactions will change. We will see it. For example, you want to draw for A or for B? Or for both?
Both.
Okay, for both. So I call it RA and RB. So what I do in the first step? In the first step, for example, this is your beam, 10 meter. I put the load at x is equal to 0. The load is 1. So if the load is 1 and it is at x is equal to 0, x is changing in this direction. So how much will be this reaction and how much will be this reaction?
1, 0.
It is RA and this is RB. It will be 0 and it will be 1. Perfect. Because when the load is exactly over the support, all reaction is going to the support. And there is no load even on this beam as well. So here 0 and 1. Okay, so you can say here when the x is 0, this is RA, this is RB. It is 1. So what about when x is equal to 2.5? Now what I do in the second case, this is the case 1. In this case, I put the load at 1 at x is equal to 2.5 meter. And then I calculate RA and RB.
0.75 for A, 0.25.
Take moment at point A. Take moment at point A. For example, I call this distance as x. So this will be 10 minus x. So RA, if I need RA, I will take moment at point B. RA into 10 will be equal to 1 into 10 minus x. So RA will be equal to 1 minus x over 10. And in the same way, we can also find RB. For example, in order to find RB, I will take moment at point A. RB into 10 is equal to 1 into x. Is this correct? So that is the most easier way to find the values. Now just put x is equal to 2.5. Put x is equal to 2.5 in this equation, you will get RA. X is equal to 2.5 here, you will get RB. So when x is 2.5, you will get how much RA?
0.25.
Okay, good. And what about this?
Half.
See, it makes sense. If the load is at the center, half. And when the load will move like
0.25.
0.25 and 0.75.
and then
0.1.
So it means the easier way is to make a function like this. I made a function based upon x and I just keep on changing the value of x and I keep on getting the value of RA and RB. Do you have any question till now? There will be maybe 1 or 2 questions in your exam.
Second. One.
One 100% sure in your second exam. Today I have to set the date for your second exam. So hold on, give me some time. So now you understand this table, how I get these values. Okay, so let's now draw the influence line diagram. When I was a student, many of us did not understand it. Influence line diagram. But it's not that difficult, I think. Easy. Okay, so let's draw the influence line diagram for both of these. I'm not saying I did not understand, most of us I said, many of the students. I used it many times when I was working in the companies, because sometimes when I have to design a beam, a steel beam carrying frame, you understand? So in that case, I have to use this influence line diagram. But I never drawn the influence line diagram. I use the absolute maximum values, which is the last thing in your topic. I shown you. I always draw. Even once I had a debate with my boss about that. He was arguing with me for a shear force. That here the shear. I mean, near this. At some location, he was arguing about the shear force, and then I brought a book and I explained him. See. And then we were both not happy with each other. We went to the manager at last, because he was a design manager. And then at the end, it happened that he said, I was saying correct. And then it was a kind of embarrassing situation for that guy. So it shows that don't take your issues to the managers. Try to settle within you. You understand or not?
Yeah.
But you can bring if you are 100% sure. If you are 100% sure on something, then you should do that. Else don't do it. Okay? Draw the influence line diagram. Okay, let's come back. So this will be the influence line diagram. ILD, I call it ILD for RB, and this will be ILD for RA. So when the x is 0, how much is RA? 1. And when x is 2.5, how much is RA?
0.75.
Okay. What I do? So when x is when x is 2.5 meter, it is 0. And when x is 0.5, it is. And when x is 7.5.
0.25.
And same way RB. When x is 0, RB is 0. And when x is
2.5.
then it is 2.25. When x is half, 5 meter, it is 0.5. And then when x is 7.5, and then when x is 10, it is 1. So now you can see these two diagrams. So these two diagrams are basically influence line diagrams for two reactions, the reaction at RA and the reaction at RB. Is it difficult?
No.
Let's go back to this diagram. So, now do you understand this diagram? Please see. The beam length is 20 meter. The length of beam is 20 meter.
We take just 2 member.
2 member?
Yeah, 2.
Two supports, because there were 2 supports. If your beam has more supports, it will become indeterminate. Do you understand?
No, it means just 2 distances.
2 distance.
Like 2. Yes.
5.
Yeah,
1,
5, 5. Or 10, 10.
10, 10, okay, 5, 5, you can do that.
Okay.
But you cannot see the exact shape. Sometimes it will not be like it. For example,
There are multiple forces.
This straight line.
sorry, it's not necessary that always it is like this. This is, I'm going to tell you in the next example. But I think now you do understand this diagram. Do you understand now?
Yes.
Good. Anyone who does not understand? Are you here?
Yes.
Really? Okay, this is the same thing. These slides are same thing. What I just explained to you. Same example when x is like 0, 2.5, so ay is 0.75. When x is 5, ay is half. So this is the same table, but this is for RA, not for RB. And then it is a diagram for RA. Okay? Like when x is 0, it is 1. When x is 2.5, it is 0.75. When x is half, it is 0.5. And when x is 10, it will become 0. And this is a function. We have drawn this function. I shown you. Now let's talk about this example. Okay? So it is an overhanging beam. Overhanging beam means this part, this is a roller, and this part is
No support.
no support, it's overhanging. So let's see now. So the best way is to write function. I told you before. The best way is to write function. For example, if you draw the free body diagram for this beam, you can see that there are 2 reactions, AY and BY. And the load is moving, and load is at a distance x. So these are the values. Okay, what I do? Let's make function first for AY. So you take a section here and you say this distance is x, and take moment at point A. You will get sigma moment at point A is 0 by into 5
And 1 into x. 1 into
is equal to
minus 1.
minus 1 into is equal to 0,
Yes.
and by is equal to
X over 5.
x over 5. And let's make function for AY. So let's take moment at point B. It will be AY,
Sigma 4 is
5.
okay, sigma 5, 1 minus x over 5.
Yeah, I want.
If you go for sigma Fy is equal to 0, so AY will be 1 minus x over 5. Okay, now let's go to this table. Please check. Put x is equal to 0.
Yeah.
And AY would be 1.
AY will be,
1.
let's also find the values for AY. AY will be
1.